Welcome to 3.8. So far, in order to prove triangles are congruent, we have side, 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 angle, side, and angle, side, angle. Today, in 3.8, we get one more, HL, which stands for hypotenuse leg. So in order to have a hypotenuse, you need to have a right triangle. A hypotenuse only exists within a right triangle. So in order to use HL, the first thing you're going to need to do is establish right angles. You don't need to say that they're congruent. You just need to establish right angles because they establish a right triangle. You don't need to say in your proof that it's a right triangle, just that the right triangles exist, or just that the right angles exist. Then you'd want to say the hypotenuses are congruent, and the hypotenuse is always the side across from the right angle. And then you would want to establish a pair of congruent legs. So the hypotenuse is always across from the right angle. And then a leg could be one or the other rays or sides that make the right angle. So when you're doing fill-in proof, by now you may have noticed that they're not always organized in the best manner, but you need to be able to follow somebody else's argument, whether it's organized properly or not. That's key to communication. So sometimes when you're talking to somebody, they'll throw in something extra. That's kind of like what that has nothing to do with anything. And that's going to happen in their proofwriting as well. But I want you gentlemen to have exceptional proofs that are very well organized and only contain the information necessary to prove your point. So we're going to start with BC is perpendicular to AC, and perpendicular implies a right angle. Then we were also given that BD is perpendicular to AD. Now, if I were writing this, I would have paired those two up, as well as lines 2 and 4. In fact, I'm going to zoom in for a minute. And then AC is congruent to AD. Now, that's a leg. 2 and 4 had our right angles. We don't need to say they're congruent. This was given. And then AB is across from the right angle, so that's the hypotenuse. And that's congruent to itself by the reflexive property. So now we can say the triangles are congruent by HL. Our right angles are in 2 and 4. The hypotenuse is in 6. And the leg is in 5. So now that we have congruent triangles, we know that the corresponding parts of congruent triangles are congruent. And if a ray divides an angle into two congruent angles, then the ray bisects the angle. Taking a look at problem number 2, I can see I'm going to get right angles, but then OF, that's going to be a leg. So rather than filling in the blank, let's try to write it in an organized manner. So we want to start with our right angles. And how we're going to get that is through the altitude. So OF is an altitude. That means that angle OFE and angle OFG are right angles, because if an altitude is drawn, then it forms right angles. This is shorter. I'm going to put right angle in the margin there. Now I want my hypotenuse. which is actually going to be OE and OG. So this is a little more disorganized than I want to work with right now, so that's why I'm rewriting it. We were given circle O, and then we know that OE is congruent to OG, because if we're given a circle, then we know all radii are congruent. And then that's my hypotenuse. Now I want my leg. So OF is going to be congruent to OF. And that's by the reflexive property. Then I have triangle FOE is congruent to triangle. Remember, I can name that first triangle however I want to. They did OEF. I chose FOE. And I can name the first triangle however I want. But once I name that first triangle, then the second triangle can only be named in one way. Since I went FOE, I have to go FOG. So triangle FO is congruent to triangle FOG. By HL, my right angles are in line 2, my hypotenuse in 4, my leg in 5. And now EF is congruent to GF. Because congruent triangles implies corresponding parts of congruent triangles are congruent. And so I did EF and GF, trying to keep that parallel structure in line. So this one's going to look a little different from what we've normally seen. Here we're given congruent triangles. I'm going to try to zoom in a little bit more there as well. So we're given congruent triangles. We've not had that before. And then KR is congruent to SW. Congruent triangles implies corresponding parts of congruent triangles are congruent. Angle K is congruent to angle S. I'm trying to clean up my markings a little bit. There we go. And then angle SWA is congruent to angle KRP. Those are all by corresponding parts. So now, if I combine these three, and 5 and 6 were given, I can say that angle KRM, which is this one here, when my pen decides to cooperate, is congruent to SWT by division. Four, 5, and 6. And then the triangles are congruent by angle side angle. Lines 3, 2, and 7. So if we look at lines 3 and 2, it really would have been very simple to just switch those two and have a nicely organized proof. And then line number 9, congruent triangles implies corresponding parts of congruent triangles are congruent. But this is from the triangle on line 8, not the one that was given. Problem number 4. MO is perpendicular to OP is given. Perpendicular implies a right angle. So if segments are perpendicular, then they form a right angle. And that's the same with lines 3 and 4. So again, I would have advocated for combining lines 1 and 3, lines 2 and 4. That's going to give me my right angles. And then MP, well, I can't really mark that on the diagram. So now I'm forced to draw a separate diagram. I think my pen's running out of juice. And that was given. So now OP is reflexive. So this actually was pretty well organized, but it would have been nicer to combine lines 2 and 4. Looking at problem 5. AE is congruent to CF is given. And I can immediately see this is going to be really disorganized. So I think I'm going to go off to the side here and write up my own. So we're given angle BFA just trying to draw out my separate triangles right away. So we're given angle BFA as a right angle. And I think I'm given right away that DEC is a right angle. So then that establishes my right angles. And I can do that in one line. So now I want to find the hypotenuse, which would be the line across from the right angle. And they gave me that AB is congruent to CD. Now I need to establish a leg. They gave me CF is congruent to AE, but that's not an entire side of the triangle. But I can see that's a part of that. So if I were to go ahead and add on EF to each of those, then I can see that AE plus EF gives me AF. And CF plus FE gives me CE. AE and EF gives me AF. CF and FE gives me CE. You can just write add. And that's my leg. So now, in line 6 here, I can say triangle. So now, remember, order matters. AFB, oops, sorry about that. AFB would be congruent to CED. And that would be by HL. My right angles are in 1, my hypotenuse is in 2, my leg is in 5. And then for the last line, angle CDE is congruent to angle ABF. Well, did so good on my parallel structure right till then. I have everything for the A triangle over there. So let me line that up. ABF is congruent to angle CDE. Congruent triangles implies corresponding parts of congruent triangles are congruent. So that should make this a lot faster to fill out. AF was given, I think. Oh no, that was addition. AB was given, as were the right angles. And then we have HL. The hypotenuse is in 2, the leg is in 3. And then congruent triangles imply CPCTC. So here we have an altitude, and an altitude gives us right angles. That's actually my hypotenuse. And then that's my leg. So HL, my right angles are in 3, hypotenuse in 1, leg is in 4. Then congruent triangles implies corresponding parts of congruent triangles are congruent. And then if a ray divides an angle into 2 congruent angles, then the ray bisects the angle. Ideally, we would have combined lines 1 and 3, 2 and 4. So BDC, and then CE is given as being congruent to DF. This is reflexive. So then by subtracting the same segment, we get congruent segments. So that's going to give me a leg. And then there's my hypotenuse, which was also given. So then by HL, my right angles are in 2 and 4, hypotenuse in 8, leg in 7. So now I can say angle C is congruent to angle F, which then would make AC congruent to AF by if the angles of a triangle are congruent, and I'm looking at the one big triangle, if these angles are congruent, then the sides are congruent. And if I have congruent sides, then my triangle is isosceles. Given circle P, PS is congruent to PV. If you're given a circle, then all radii are congruent. ST is congruent to VT, is also given. Then draw PT, because 2 points determine a segment. And then PT is congruent to itself by the reflexive property. So then PST is congruent to PVT by side, side, side. 2, 3, 5, which then would make angle PST congruent to PVT, because congruent triangles imply corresponding parts are congruent. So CD is congruent to EF. I think we should just write this one out from scratch. And JF is perpendicular to JD. That one's perpendicular as well. So that gives me a clue that my triangles are going to be JDF and HED. And then they told me CH. Oops, I got one of these letters wrong. It's got to be a C. CH is going to be congruent to JF. So looking at this right now, I know that I'm either going to have side, 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 angle, side, angle, or HL. Since I have the right angles and a side plus this part equal with this part, I can use addition to get CE congruent to FD. So I'm going to organize this as an HL proof. So I'm going to start with JF is perpendicular to JD, and CH is perpendicular to HE. And that's my right angle. Now, the repeating letter is the vertex. So F, J, D, and CHE are right angles. Because if two segments are perpendicular, then they form a right angle. So I got a little ahead of myself there. So that's my right angle. Now I want the hypotenuse. They gave me that CD was congruent to EF, keeping all of the parts for this triangle on the left, all the parts for the CHE triangle on the right. And that's just my preference for the parallel structure. then 4. So what do I have to add to EF to get DF? Isn't that DE? And then what do I have to add to DC in order to get EC? I think that's ED. And that's by the reflexive property. So now, ED plus EF gives me DF. And CD plus DE gives me CE. So maybe I should switch the order of these. Oops. CD and DE gives me CE. So there I'm adding the same segment to concurrent segments, and that gives me concurrent sums. And then we have JF congruent to HC, and that was given. So now I have triangle JDF congruent to triangle HEC by HL. My right angles are in 2. My hypotenuse is in 5. And my leg is in 6. And then last but no least, segment JD is congruent to segment HE, because if we have congruent triangles, then the corresponding parts of those congruent triangles are congruent. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.